can be interesting for you guys, and I'm trying to give you more information about all these that you might need. So retaining wall and anchored face wall and rebar, yeah, and anchored and face wall rebar. So we have different types of retaining wall. As you can remember, last week I mentioned some for nail walls or tieback walls or anchored wall. We call them with different. As soon as you install those, then you have to cover this with shotcrete, as you saw that on last week. And then after that, because at the end with shotcrete is not good looking wall for actually just leave it there in at the middle of the city. So it's better to do something special and cover that as a face bar. As you can see, they are doing something to cover that part. And with sometimes with additional, not sometimes, always with additional rebar, then install form. And those forms, most of the time, they have some actually shapes on them. As soon as they pour concrete, the shape will be transferred to the concrete. And when they remove that, you can see a lot of shapes, molds or whatever. It depends on the architect actually plan for this wall. And for this high wall, something like that, without any texture, it looks not that interesting and can be looks ugly, especially at the city, inside the city. And right now, they are doing a very nice, actually, architect texture on any wall. Some walls are just like a footing and stem. The vertical part, we call that a stem, and the horizontal part on the ground, we call that footing and a stem. So rebar installation, you can see we need rebar for bending on the footing, plus bending on the wall, because dirt will push this and the rebar will act like a rebar inside the beam, because that's a bending element, the stem. And footing as well, footing will work as a shear and bending like a beam. So both of them will be designed like a beam. That's another type of the wall. On Caltrans, they call that type 1. So the stem will sit almost at the middle of the footing. Yeah. So we call that type 1 wall. Something like this. You have footing that side, you have footing this side, and a stem is something between. Sometimes there is no room. That's the end of your actually land. So you can't put some of the footing inside the land. So you will get L-shaped wall. So it depends on what you have. Sometimes for a small wall, most of the time around the backyard of the houses or something, they are using retaining wall with the blocks, as you can see, plus vertical and horizontal bars. So it will act like a actually retaining wall. Then they will backfill this, and they can actually use this as a backyard with grasses, trees, and whatever they want for that structure. As you can see, these are different texture that as you can see looks very good. Sometimes not that much. And another texture here. So we call these MSE walls. So you can see here retaining walls, MSE wall. Yeah, MSE wall, mechanically stabilized earth. Yeah, MSE wall. So what are they works and how they works and how they can build them? It's very interesting. And if you haven't heard that, I think these slides will give you a lot of information and you might love them. It's like a puzzle. Look at this. They set one by one puzzle. They will start with this small part, then this one, then this one, then that one, all the first row. Then they do something backside. And when it's completed, then they install the second part. Yeah, and then they set the dirt back here backside. Then they go with they install this as a puzzle, and they do backfilling bats at the backside, and then they will keep going all the way to the elevation that they want. So if they have texture, they have to mark them. When they pour concrete in another place, they deliver them. They have different names, number 1, 2, 3, 4, 5, whatever they want. They put name on it, so they know which one will go where. So otherwise, if they miss them, sometimes you cannot do anything, and the texture is not actually for the location that you want. So it's critical at that time for the naming and the location. Those are MSC wall most of the time at the both sides of the bridges. We are using them, and it's very good actually method for almost very tall retaining walls. So MSE wall. So how we can build them, it's the step by step you can see on these pictures. As you can see, it has a very small footing. It's just with no rebar. It's a pad just for leveling pad. Yeah. So that's a leveling pad about maybe 6-inch thick and about 1 foot wide. That's it, with no rebar. Just make it completely level. Then they will the elevation based on the plan. Then they start installing the first row of these MSC actually those uh, what was that the name that I mentioned? Puzzle, like a puzzle. And you can see they have a lot of actually stuff for holding them. Those are holes, and there is a bolt inside. Then with the crane, they add this bolt inside that actually not inside this, and then they can move it and install it at the location, make it stable. Look at this. These are the system that they are making them stable at any level. This is the first row. You can see. Yeah. So they are making them stable. And then behind that, what's behind that? It's not just concrete. Then if you put dirt behind this, it's not stable. Yeah, if they are not connected to something. How they can connect those stuff? There are a lot of actually stuff at the other side with some straps, and then they will backfill that on top, and they will compact it over the straps. It can make them stable. How? There's a slide, you can see all these. So as you can see, this is this yeah, not front side of the wall. At this side of the wall, behind those, each those segment has 4 of these, 1, 2 at the bottom, 2 on the top. So and then there is a hook here. They will add this to that hook and put a bolt and a nut and make it completely hard at that location. So all this will go to the back side of those uh, segment, each small segment. Yeah. Then they put this backfill material. The backfill material should be accepted by the designer based on the actually all the stuff that they want. It can be just native material. No, those are good base material. So they will spread on top. Then they have to compact it to 95 and over 95% to 98%. And then the friction, these are not completely smooth. They have actually ups, down, ups, down, something like that. So when they put dirt and they compact it, it can create a huge friction. Yeah, that's one method. We call them straps. So with these straps, as soon as they put this, and the length of them, those are must be designed based on the friction that we need, because those are holding this face wall. Yeah, nothing else with holding this face wall, just these straps. Another system that they can use instead of those straps, there is actually a plate or angle inside this, and then they are putting a mesh. Then they connect the mesh to that backside of this, the same as the other one at the bottom, one at the top at each segment. Then they backfill on top of this. Or sometimes recently they are using foam concrete. That's a lightweight concrete. They install this, then they pump that. There is no compaction for that. Just from actually from the concrete truck, they are bringing with trimming, and they put all those actually concrete, foam concrete for the whole length. And the next day they can walk on top of that, then they will install more, and then the other part, then another foam, or with this. So either one can be. Here they use a backfill. So they put the same material and they compact it on top. Yeah. And as you can see, there are all the stages you can see on these pictures, how to actually construct MSC wall in actually this kind of retaining walls. So I hope you like kind of retaining walls. They can start from zero and just install those straps, backfill, install, strap backfill, install, strap backfill, and keep going. But the guys that they are installing them, they must be very expert. There are a lot of failure in this. If they are using bad material for backfill, there are very a lot of actually failure. The whole part just failed or start going this way, so they have to remove everything. Just it's not that easy. They must be expert. When they install this, they're sometimes most of the time they are going inside first, because as soon as you put dirt and backfill this, the pressure will push the wall backside to this side. So if they don't know that and they install them plumb, at the end they will get something like that. Then they have to remove everything. So those guys must know all this stuff to be able to install them correctly with no failure or no actually deformation. Otherwise, it should be huge mess, and they have to fix that, remove them, and fix them, and it's very costly and hard actually process. So as you can see, another retaining wall with rebar and form, and as you can see, those are normal and retaining walls. So they install the rebar, concrete pour for the footing, then install rebar for the stem, set forms for the stems, pour concrete for the stem, strip the forms, cure the concrete, then backfill that. Yeah, then when the concrete is strong enough, they can backfill the dirt behind. Then everything is ready for using this wall as a retaining wall, like here or whatever. This one without actually backfilling. They didn't backfill them yet. So I think that's a quick review for retaining wall, and that's it for so for today, retaining wall and MSC wall, and before this, we talk about anchored wall, soil nail walls, and all of them are using for retaining dirt behind them in order to give us enough room for the different structures like roadways, like just anything in front of those parts that we need to have for constructing a new building or whatever we need. So retaining walls are very special structures in our engineering to create room for different actually structures like roadway or different buildings in front of them. So that's good enough for today. And if you have any question, please let me know. Any question on these slides or other stuff?
No, thank you.
Okay, thank you. If you have no question, that's enough for tonight. Thank you for
Thank
being a
you.
good engineer, and see you next week.
Professor,
Yes,
can I talk to you after everybody goes, or would that be okay?
sure. Yes.